Hello, and welcome to a second in a series of live Ask the Expert events. During today's event, our expert will be answering your questions on IPv6 and its best practices. My name is Kent Wong, and I'm a program manager in the customer advocacy team. Our expert joining me today is Harold Ritter, a technical leader within Cisco Advanced Services Central Engineering team. Harold is responsible for helping Cisco's top-tier service provider customers to design, implement, and troubleshoot routing protocols and multicast for both IPv4 and IPv6 and MPLS solutions in their environments. He has been a network engineer for more than 14 years. Harold is a CCIE number 4168 for routing and switching and service provider. Welcome, Harold.
Thanks, Ken. I'm glad to be here today.
Great. Prior to getting started, I'd like to briefly outline the agenda for today's event. For the first 25 minutes of the program, Harold will be giving an update on IPv6 and its best practices. He will then address how to deploy Internet Protocol version 6 in a service provider environment to cope with growing demand. Following the presentation and for the remainder of the time, there will be a live Q&A session where Harold will answer your questions. You're welcome to submit questions during the presentation, which Harold will address. We also have a team of Cisco engineers on hand to answer questions or route them appropriately to Harold. Our team is well versed in the technology being covered, and in order to give them time to review your questions, I encourage you to submit them early. Please post your questions in the Q&A panel on the right-hand side, and we will address them during today's event. Throughout this presentation, we will also be asking a few polling questions. Let's start with one now. So our first polling question is, how would you qualify your IPv6 expertise level? Would you say you're a beginner, intermediate, or expert? Please take a moment to answer this poll by using the pane in the lower right-hand side. I'd like to now hand the mic to Harold, who will give us an update on IPv6. Harold, please take it away.
Thank you. Okay, so in today's presentation, we'll be focusing on a few tunneling techniques that you can leverage to ease your IPv6 deployments. These techniques are actually classified into two main categories. So the manually configured tunnels and the automatic tunnels. So we'll start with a manually configured tunnel example, and namely IPv6 over IPv4. So in this case, we have an IPv6 network on the left-hand side and another one on the right-hand side. And the goal, obviously, is to transparently be able to connect these two IPv6 networks. We have an IPv4 cloud in the middle, and we will actually need to deploy like dual stack routers, and dual stack meaning that they run both an IPv4 and an IPv6 stack, and connect them to the IPv4 cloud. So if traffic needs to go from the IPv6 host on the left-hand side to the one on the right-hand side, it will first be forwarded natively over the IPv6 network to the dual stack router. This router will insert an IPv4 header or encapsulate the IPv6 traffic over an IPv4 header and forward it to the other dual stack router. This other dual stack router will then in turn remove the IPv4 header and forward the packet natively over IPv6 to the second host on the right hand side. So just to note that the protocol number that will be used by IPv4 will be protocol number 41, which is IPv6 over v4. So in the previous example, we actually did set up a tunnel between two dual stack routers. I just wanted to also illustrate that it was also possible to have this same tunnel connectivity between a dual stack host and a dual stack router. So it's very common with Microsoft operating systems to actually set up IPv6 over IPv4 tunnels this way. So if we look at the actual configuration, or all this would look like in terms of configuration, so we have again our two IPv6 networks interconnected, or isolated IPv6 network connected by the two dual stack routers. And the IPv4 address of the dual stack router 1 is 192.168.99.1, and we use 30.1 on the other side. So on the tunnel interface as such, we will need to enable IPv6 first, and that's what our first statement is for. We will then assign an IPv6 prefix on the tunnel interface. We will then configure the source and the destination IPv4 addresses, and in this case you can see that the source is the 99.1, which is our local IPv4 address, and the destination would be the 30.1, which is the IPv4 address for the other dual stack router. And the mode obviously would be set to GRE IP, and the keyword IP in here is actually to differentiate between GRE over IPv4 or GRE over IPv6, which is also possible. This configuration example is actually the exact same as the one before, but this time it is for a manually configured IPv6 over IPv4 tunnel. So the only thing that changes in here is actually the tunnel mode, which is set to IPv6 IP instead of GRE. So let's talk about the automatic tunnels now, and we're going to talk in this example more specifically about 624 itself. So as we saw in the previous example, I mean, the goal of the tunnel is actually to reconnect two isolated IPv6 network over an IPv4 infrastructure. So unlike the manual tunnels as we saw before, which were basically point-to-point techniques, the automatic 624 is actually a multi-point tunnel technique. So at this point, you won't be able to configure the tunnel destination on the tunnel interface itself. So how do we actually forward packets to the proper router if we don't have the tunnel destination configured as such on the tunnel interface? Well, the answer is simple. We actually use or embed the IPv4 address in the IPv6 prefix as such. And the address format will be the prefix 2002 followed by the 32-bit IPv4 address. So this will give us a automatic 624 tunnel prefix. So let's look at an example here. So we have pretty much the same scenario we had before, but this time we're going to use automatic 624 instead of using a GRE approach, which is a point-to-point. So in this case, we have a multi-point tunnel. Although we're only showing two sites, we're going to show some additional example that will let us see that this is a multi-point technique. So again, we have the 192.168.99.1 that has been assigned to the 624 router on the left-hand side, and the 30.1 to the 624 router on the right-hand side. So to actually create the, we will create an IPv6 prefix out of that IPv4 prefix. So the 2002 is actually a 16-bit prefix, and the IPv4 being 32 bits, we will end up with a 48-bit prefix, IPv6 prefix that is. So we need to do that for each and every site that we add to the 624, to the automatic 624 network. So on the other side, we'll do the exact same thing. We'll have the 2002 prefix, and we'll encode the IPv4 address as the next 32 bits in the IPv6 prefix. So that will give us a /48 IPv6 prefix as well. So what will we do with this /48 IPv6 prefix? We will actually address or number the entire local IPv6 network. So all destinations within that site will need to be configured with this /48 prefix, or out of that /48 block. So if we look at this this scenario, we added actually a third site. So the third site has an IPv4 address of 192.168.20.1, and we derived an IPv6 prefix out of that IPv4 address. Again, the technique is the same one as we saw before. So just a reminder that this IPv4 infrastructure that we're showing in the middle, it can be just a single subnet, or it can be the internet as wide as or as big as the internet actually. So if we just jump now to the router configuration for automatic 624, and we'll see router 1 is configured as follows. We have the Ethernet 0 interface, which is the interface facing the IPv6 network. And notice that the prefix, the /64 prefix that has been assigned to Ethernet 0 has been allocated from the /48 that was built for that site, and that was derived from the 192.168.99.1. So if traffic flows from the right-hand side IPv6 network to the local 624 router natively, the destination address of the tunnel will be actually derived from the destination IPv6 address. So in this case, this is why we require that all networks, all subnets, all interfaces in the local IPv6 network be numbered with the same /48 block. So if we continue with the configuration example, interface Ethernet 1 is the one that is configured with the 192.168.99.1. And if we look at the tunnel interface itself, we configure it with an IPv6 unnumbered. We then continue with the tunnel source of Ethernet 1, which is our interface that has the IPv4 address assigned to it. And we then continue with the tunnel mode, which is IPv6 IP 624, to specify that this is an automatic 624 tunnel. The last statement is actually to tell the router to send all traffic with a prefix of 2002, so all traffic that is related to automatic 624 to the tunnel itself. So let's talk about ISATAP now. So unlike the protocols that we've seen before, or the techniques that we've seen before, ISATAP has been specifically designed for to establish an IPv4 tunnel between a host and a router. So it's been defined by RFC 4214. It is widely used in enterprise and academic networks. It's a scalable approach, obviously. You can deploy one ISATAP router and have many hosts connected to the same gateway. And as we will see, ISATAP make the IPv4 infrastructure look as an NBMA network. So we'll see that in more details in the next following slides. So if we start with the IPv6 address format for ISATAP, we'll see that it has something similar to the automatic 624 technique that we just looked at, in the sense that the IPv4 address is encoded in the IPv6 address itself. So this is again used to make the tunnel destination being learned dynamically instead of statically or manually configured. So the first 64-bit will need to be allocated from one of our IPv6 blocks internally. The next 32 bits will be a fixed value that is assigned by the RFC to 0000:5EFE, and it will be followed by the IPv4 address of the gateway or of the host. So I just want to mention as well that ISATAP is widely supported, Windows XP, all more recent operating systems on the Windows side. It will also be supported by Linux, FreeBSD, and many other operating systems. So let's look at a real example of ISATAP and how it all works. So in a normal stateless auto-configuration scenario in IPv6, the host would actually send a router solicitation message to the router, and the router would and that message is actually used to find out if there is an active router on that subnet, and the router will respond with a router advertisement message, letting the host know that there is actually a router, an active router on this subnet. And it will also tell the router what prefix it needs to use if it wants to have IPv6 connectivity out of the local subnet. So what's particular in the case of ISATAP is that instead of having all of that happening on a local subnet, you actually have that happening over an IPv4 tunnel. So if you look at on the left-hand side, the IPv4 source for the message will be the local IPv4 address, and that's the same address that will be encoded actually in the as the 32 last bits of the IPv6 address. And for the IPv4 destination, this will be the IP address of the ISATAP router. So how does the host find out about that address or the ISATAP router address? There's two ways to do this. You can actually configure this address statically on the workstation, on the host, or you can acquire it via DNS, which is a technique that is most likely used by all of the customers that I've worked with, that I've deployed ISATAP. So let's go to the next slide. So at this point, after acquiring the IPv6 prefix from the ISATAP router, the host will need to start sending traffic, but it first needs to complete the IPv6 address that will be used locally. And as I said before, right after the /64 IPv6 prefix, you would insert the 00, or the host or the software would insert the 0000:FE 5VFE, and followed by the IPv4 address of the workstation into the IPv6 address. At that point, this will create an automatic and a dynamic IPv4 tunnel between the ISATAP router and the ISATAP host. Or if you want the ISATAP router, just by looking at the IPv6 prefix, the destination address of the destination IPv6 address, will be able to derive the IPv4 address of the host and send the IPv6 prefix over or the IPv6 packet over the right tunnel.
Thank you, Harold. Good presentation so far. Now we have our next polling question. If you would take a moment to answer this polling question. Do you work for a service provider or an enterprise? Please select your answer by using the pane in the lower right-hand side. Give you a couple of seconds to do that. All right. Now I'd like to hand it back to Harold to continue with this presentation.
Thanks, Ken. So in this other slide, we just show that a third or that a second host B in this case has come online, and you see that if you look at the IPv4 address of this host, it's actually not on the same subnet as the first host. But even though it's not on the same IPv4 subnet, it will get a prefix, an IPv6 prefix that is out of the same /64. So it will get exactly the same IPv6 prefix as the other host. If we now look at the configuration as such on the ISATAP router, it's pretty straightforward. You have, again, Ethernet 0 that's facing the IPv4 network that has our IPv4 address that will be used as the source for the tunnel, the IPv4 tunnel. And if you now look at the interface tunnel 0, we assign an IPv6 address, and you see that this IPv6 address or prefix that we assign to this tunnel 0 interface is the one that we will be advertising to the host. Next, we configure the tunnel source, so referring back to Ethernet 0, which is our IPv4 or interface facing the IPv4 network, and we then set the tunnel mode to IPv6 IP ISATAP to specify that this is actually an ISATAP tunnel. So just to mention that ISATAP is used by several customers that I know of. We've been using it at Cisco to give IPv6 internet access to internal users, and I've been using it myself for a number of years, and it's worked like a charm. And it's a very easy service to deploy. So I would encourage people who want to give a first try at IPv6 to go with ISATAP and try it today. Okay, let's talk about IPv6 over MPLS now. So it is clear, as everybody knows, like a lot of service providers have deployed MPLS in their network. So we can take advantage of that MPLS network to deploy IPv6 services in an easier way than just deploying V6 on all routers. So the first technique, the first approach that would be used to provide IPv6 services to a customer would be to run IPv6 over MPLS or IPv6 over Ethernet over MPLS. So Ethernet over MPLS provides a piece of Ethernet wire from one customer site to another customer site. So at this point, the only thing that the customer would need to do is run IPv6 over that piece of wire between the two routers connected to that piece of wire, and it would be it. So the service provider doesn't even need to be involved, or doesn't even need to configure any IPv6 in its network. It would all be done automatically. So this is a point-to-point approach, obviously. But as the E over MPLS is a point-to-point service in nature, but it would work very easily. Let's talk about the IPv6 provider reg or 6PE and the IPv6 VPN provider reg or 6VPE in more details. Let's start with 6PE. So just to mention that 6PE is actually defined in RFC 4804. It is a way to provide global IPv6 connectivity over an IPv4 MPLS infrastructure. It's a transition mechanism, just to ease the transition of, from IPv4 to IPv6. And it is also like a coexistence mechanism for both IPv4 and IPv6 services over MPLS. So if we quickly look at the diagram, the first thing I want to mention is the global connectivity nature of 6PE versus 6VPE. So in this diagram, if you look at all the V6 customer sites connected to the MPLS core, they would all have access to one another. So there is no separation between one customer and another. But that's perfectly fine for an internet type of service. So in this case, all of the customers can happily talk to each other. Next thing I want to mention about 6PE is that you don't need to upgrade all of your edge routers or aggregation routers to deliver that service. You just need to implement it on aggregation routers where there is actually V6 customers connected. And one more thing to mention is that the P routers that we see in the middle, they're not even touched by this implementation. So they wouldn't need to run V6 at all. So the only routers that would be dual stack in this picture are the routers marked as 6Ps. Next thing is, so how do we propagate the V6 information from one 6PE to another? And I'm talking more specifically about the routing information if the P routers are not involved. Well, we do that via IBGP. So IBGP would be used between the 6PE routers to propagate IPv6 information. We would use a new class, so we talk about MBGP in this case, multi-protocol BGP, and we would use a different address family for that to happen, and it would be in this case IPv6 unicast label. So let's give an example now of how traffic would be forwarded from, let's say, the top left customer side to the right the top right V6 side. So the traffic would first be forwarded natively from the customer side to the 6PE. The 6PE would take that IPv6 traffic and encapsulate it into a label switch path, or LSP. This would take the traffic throughout the core as an MPLS, as MPLS traffic, and to the egress 6PE, which would remove the remaining tag and forward the traffic to the customer side natively. So let's talk about 6VPE now. The only variance, actually, 6PE and 6VPE are very similar. The only difference is that 6VPE provides VPN access. So now the customer, all V6 customer sites cannot necessarily access one another. They will only be able to access sites that are within the same VPN. This is very similar. This is actually the same thing as what MPLS VPN or L3 VPN is for IPv4. So if we look at the picture right away, again, now we say that a customer could run like both V4 and V6 inside a VPN, but in this picture we actually have two VPNs, two different VPNs, VPN blue and VPN yellow. So all of the VPN blue sites would be able to access one another, but that would be limited to this VPN. So as with before, with the 6PE technique, all of the IPv6 routes were installed in the global routing table. But now with this technique, the routes are actually installed into a routing table that is particular to one VPN, which is called a VRF, a routing and forwarding instance. So again, the same technique would be used to propagate the updates from one VPN site to another VPN site through the core. It would be with IBGP, MBGP more specifically, multi-protocol BGP. And in this case, we would use address family VPN v6 for those who are familiar with the BGP address families. And again, if we just look at how we would propagate a packet from the blue VPN site on the left-hand side, the top left-hand side, and the one on the right-hand side, we would just forward the traffic again natively from the customer side to the aggregation box. This aggregation box would take the IPv6 traffic and insert it into a label switch path, just the same as it is done with 6PE. This LSP would take the traffic to the egress PE, which would remove the remaining tag and use the remaining tag in this case to select which VPN needs to receive the packet, and this packet would be forwarded natively via IPv6.
All right. Well, thank you, Harold. That concludes the presentation section of our webinar. We have one final polling question prior to beginning the Q&A session of this webinar. So our last polling question is, when are you looking to deploy IPv6? Within 2 years, within 3 years, within 6 months, within 3 months, or not applicable? So I'll give you a moment to try and answer that. As before, please answer this question by using the pane on the lower right-hand side. All right, a couple more seconds. All right then, now we will begin our Q&A session with Harold. As mentioned before, please post your questions using the Q&A panel on the right-hand side. Harold will answer them as they come in. So Harold, please take it away.
Okay, so our first question is the following. Will there be any materials on IPv6 multi-homing included in the presentation? Not as such. You know, we will not be talking about we haven't discussed IPv6 multi-homing, but there is tons of material on CCO that is available, you know, concerning how you would address the IPv6 multi-homing technique inside BGP. There's a second question. What are some of the challenges of IPv4 and IPv6 migration in the SP world? Well, I would say I've worked with many IPv6 service provider, or many service providers in the last couple of years, and the biggest challenge now is actually for them to build a business case. You know, like so. If they go out and you know, and ask their management to support an IPv6 deployment, and you know, IPv6 not being like any different than any other deployment, you know, it's likely that this IPv6 will create some issues, or you know, like there's probably some problems that will show up during the IPv6 deployment. Now. You know, if you go to your upper management and you just ask them about, you know, like for approval for IPv6 deployment, and you don't have a clear business case to support your request, that can be hard, you know, hard press sometimes. And but you know, like lately I was hearing somebody telling me about this, and he said that their management actually came to them and asked them to deploy IPv6, because he said, no, we don't really need IPv6. You know, there's no killer apps. There's nobody pressuring us to deploy it. But, you know, when times come, you know, like we won't have time. I mean, we won't have any leeway, you know, or chances to fail. You know, we will need to get it right the first time. So, you know, the whole thing behind his strategy was to do it right now, while it is possible to commit mistake, to make mistake, and to get away with it. So that would be my answer. Okay, so there's a question about Mac OS, and yes, I mean there's a support for IPv6 on the if you look at Snow Leopard, there's all the IPv6 support you need in there. I haven't personally done it myself, but I have friends who are using Mac here at Cisco, and you know, like IPv6 works like a charm on this platform. Let me take another question. Okay, so there was a question about what is the function of the no IPv6 and the suppress RA that was shown in the ISATAP example. So usually the RA, the router advertisement message, will only go out on NBMA interfaces, or more likely Ethernet interfaces. So and the default is actually for RA to be suppressed on non-Ethernet interfaces. So in this case, we need to have a router advertisement functioning, working on a tunnel interface. So this is why we were using the no IPv6 and the suppress RA. So this is actually an excellent question. So there's a question here asking about if your ISP doesn't support IPv6, is the only option manual tunnel, or can we use GRE tunnels? Actually, a GRE tunnel is a manual tunnel, by the way. It's just that will allow you to do things that you wouldn't be able to do with, IPv6 over v4 in a sense. Yes, so I have seen people like using all kind of techniques, but yes, tunneling, if your service provider doesn't offer IPv6, I would first tell you, well, go and put pressure on your service provider. I've seen a lot of customers doing that, and usually service providers will be responsive to such a request. They all know that they have to deploy IPv6 at some point. It's just a matter of when to do it. So the best way to get your service provider to offer that service is actually to go knock on his door and just show the interest for IPv6. But yes, in the meantime, even if you go and do that, it's probably not going to happen, overnight. So the option at that point will either be to change service provider or to add a second or a third service provider who offer V6, or to do IPv6 tunneling. There's a question about AT&T, Sprint, and Verizon IPv6 readiness. And I believe that most of them already have, plans to deploy IPv6, or they already deploy it. If I can think of Sprint. Sprint has been ready for IPv6 for a long time. So I'm not specifically sure about AT&T and Verizon, but I know that Sprint for sure has been V6 enabled for a long time. Let me go pick another question now. Okay, so using ISATAP, will I be able to use a firewall software module in transparent mode to provide IPv6 to my client? And the answer to that would be yes. One of the advantage of ISATAP is that you can easily run it on RFC 1918 addresses, and I don't know of any limitation that would prevent you to actually have an ISATAP tunnel traversing a firewall module. So let me go to the next question. So there's a question here asking me about what do we gain from going to IPv6, and that's a very common question. I see that question all the time. And the answer is not clear, because we all know that the IPv4 address block depletion is coming. There's people talking about the end, most likely the end of 2011. So I don't know if it has anything to do with 2012, but you probably saw the movie. But anyway, so we all need to get prepared for that. It's just that at this point in time, we don't feel the pain of not having IPv4 addresses, which is actually clearly not the case in Japan and in Asia Pac, where people are a lot more prone to deploying IPv6 for that very specific reason of IPv4 being very scarce and being very rare over there, which is not the case here. I was again speaking to a service provider yesterday who was telling me, even though the IPv4 pool will be depleted by the end of 2011, and he was telling me that they probably have enough stock of IPv4 addresses to go another 2 years. But I mean, it is clearly not the case for everybody. So I think we all need to get prepared for the next internet, the internet IPv6. And I know it's going to be hard. It's going to take a while, but better prepare right now than come to a complete stop in 2011 and not having at least plans to deploy IPv6. So let me pick another question. Okay, there's been many debates on the IPv6 address assignment on point-to-point interfaces More specifically, assigning a /64 versus a /126. What have you seen in some of the SP networks for the addressing methods? Again, this is, as you said, like a debate that's taking place right now. On one side, people say, well, let's keep it a /64 all over the place, because you know that on a Ethernet interface, if you want to run like stateless auto configuration, you will need a /64 prefix on that Ethernet interface. But people have problems, when it comes to assigning a /64 prefix on a serial link between two, a point-to-point link, when only actually two addresses would be required. So I would say that there's no right answer. I know that the /126 is definitely something that you can deploy. It's just that it's not going to make your addressing plan the same across the board. But if this is something you're ready to go with, I don't see any problem with using a /126. And as I mentioned, as you may or may not know, you mentioned the /126, and this is a good point, because you couldn't use just the same. We could use a /31 with IPv4. In IPv6, you could not use a /127 because of the anycast address that could potentially be a conflict at this point. So there's a draft or an RFC out there that mentions that if you want to go with a the smallest prefix that you could assign on a serial interface would be a /126. So let me pick another question now. So here's the question about do GSR's 12,000 routers supports IPv6? And the answer to that is yes. But you should be aware that if you want the engine to forward the IPv6 traffic in hardware, you should have either an engine 3 or an engine 5. So that's the restriction related to using IPv6 on the GSR. So again, this is something, if we look at it more globally, there's certainly like an assessment that should be done over your infrastructures to see that all routers, the hardware that you have in your network do support IPv6, and that they support it up to your expectations. Some level of hardware, such as the engine 2 and engine 4 on the GSR, will only support it in software. So it might be fine, given the level of IPv6 traffic that you're seeing on your network. At this point in time, most service providers that I deal with see a very small amount of IPv6 traffic on their core. I was talking to someone earlier this week, and he said that it's probably in the order of 1%. So 1% of its traffic is IPv6 and 99% is IPv4. So at this point, you might start questioning if you want to have if you couldn't get away with hardware that's not forwarding traffic at in the hardware. So let me pick another question. So the question here is there an advantage of doing V6 tunneling instead of using a dual stack? Well, again, in the examples that I've given before, the IPv4 infrastructure that I was showing in the middle might not even be your infrastructure. So even if you wanted to go and deploy V6 natively over that IPv4 infrastructure to make it a dual stack infrastructure, if you want, it wouldn't even be possible, because this is out of your control. This IPv4 infrastructure that I was showing might even be the internet for all I know. It would be possible to run like a tunnel over the internet. So or the other thing that could prevent you from deploying IPv6 over a given IPv4 infrastructure to make it, both, or to be able to support both IPv4 and IPv6 natively, would be that you have old hardware in your IPv4 core that doesn't support IPv6. It could be as simple as that. So there's many things there to look at in order to decide whether you want to go with a more native approach, or if you want to go with IPv6 over IPv4 tunnels. But it's most certainly that, and you probably got to appreciate that in my presentation today. Like using tunneling can sometimes make your life very easy. At least if you want to deploy, V6 strategically in your network. Okay, so let me go and pick another question. Okay, so there's a question about is V6 better than IPv4? Well, I don't know that it's better. It's just that it provides more, addresses. So this is the big problem at this point in time, is that we need more addresses, and there's as you know, like there's a lot of deployments going on where let's say LTE or 3G, 4G networks being built all around the world, and these networks obviously require a lot of addresses. Doing it over IPv4 is pretty hard these days, and a lot of service providers are considering going to IPv6 for that purpose. But yeah, I mean, the bottom line, I mean, the question, at the bottom line of this is do we, like whatever we do, I mean, are we going to be able to go very far? Like if we don't migrate to IPv6, it's just a question of adding more addresses. And, like I know that the internet currently needs more addresses. What about network applications that are designed for IPv4 but run on modern server OSs? I think that it is most likely that if you do have like a dual stack a router, that this wouldn't be such of an issue. There's probably legacy application that will have some issues running over IPv6, but unless like the application does some funky stuff, I don't see why why an application could not be moved to IPv6. I think that it's going to be up to the server. If the server is configured for both IPv4 and IPv6, it should be fine. Clients should be able to access that same application using either one of the two stacks. So let me pick another question. Okay, so here's another question. Any Cisco predictions on to U.S. adoption of V6 after V4 address exhaustion? Will this be like metric? I'm not sure exactly what this means, but let me try to address the first part of the question. I mean, it is certain that, as I said before, that there's not the same urge of deploying IPv6 in the U.S. as there is in Asia-Pac, for instance. But I think that a lot more. I mean, I've seen it lately. I mean, where we have internal support groups at Cisco supporting IPv6, and these internal support teams were not getting a lot of traction. Just because not a lot of people had customers deploying IPv6, but today it seems like everybody wants to at least wants to deploy IPv6 or wants to have a plan to go down that route. So yeah, I mean, I think that there's going to be a lot of activity, IPv6 centric activity between now and the end of 2011, and it will definitely continue after that as well. So let me take another question. Okay, so I have another question here. It goes like this. Please, can you briefly discuss recommended methodologies for V4 to V6 migration in an SP environment? And I think that, I've seen service providers wanting to deploy like IPv6. The way to do it is actually that they go and do it, on a tactical basis. So they will deploy wherever it's needed. And 6PE is very good for that. It will allow a service provider to actually allow a service provider not to have to go and deploy IPv6 everywhere. Having to touch all of the core routers and all of the aggregation routers in a service provider network is a major undertaking. And this is, that's where like a lot of service providers are afraid to move to IPv6. Again, like it comes back to that business plan, right? Do you have like a business plan, business case to do that kind of work? Or, do you have like one customer coming to you and asking for V6 services? If you do have IPv6 transit on one box, for instance, and an IPv6 customer attached to another box, if you do have MPLS infrastructures in the middle, it makes it very easy to just run 6PE between these two aggregation routers, the one that connects to the transit and the one that connects to the customer, and give the customer an IPv6 service this way. As you have more IPv6 customers, you can do it gradually. And as you have more IPv6 customers coming online and asking you for IPv6 services, you can deliver that service on a router per router basis, and that will definitely buy you additional time to deploy IPv6.
Thank you, Harold. I see like we're coming up to the top of our hour right now, so I'd like to say a few closing statements before we conclude today. So if you could please advance to the next slide here. So thank you everyone for attending today's webcast, and thank you for your participation. I want to let everyone know that if you have further questions on IPv6, you can visit the Cisco Support Community, where you will find support help, articles, and documents, and really continue your discussion there. You can log in at the URL shown on the screen. In addition, today's webinar will be posted within the next 48 hours on our YouTube channel, as you can see indicated on the screen. And also, to connect with us and hear about our upcoming events, please visit our Facebook page. It's a rather long URL, but if you search for Cisco Support Community .pro, you should be able to find it. Once again, we appreciate your attendance and participation today. We will be sending you a brief survey later today in regards to this webinar. Your responses will help us improve our future events. And from everyone here at Cisco, I want to extend our appreciation and thanks for your attendance. Thank you.